In the previous sessions, we learned to balance the chemical equation. We have also seen 7 different examples of balancing a chemical equation, and now finally we are left with 2 more equations. So here is the 8th equation that I told you, where you would face certain difficulties in balancing this. Okay, it looks very simple. That is, reaction of sodium with water to form NaOH plus hydrogen gas is released. Okay, now there is a difference between the previous equations and this equation. I will tell you how. Okay, so what is the first step in balancing a chemical equation? First, we have to check if the reaction is balanced or not. So to check this, we have to go with what? Atoms. So here we have sodium atom, hydrogen atom and oxygen atom. So when I look at the reactant side, sodium is only 1, whereas on the product side it is also 1. Whereas hydrogens, here there are 2 hydrogens on the reactant side, whereas on the product side I have 1 plus 2, in total 3 hydrogens. Correct? Then let's look at oxygen. So if you look at oxygen, I have 1 oxygen here, whereas on the product side also 1. So that means my sodiums are balanced, oxygen is balanced, but whereas my hydrogen is not balanced. So the equation is a skeletal equation, correct? So that means I have to balance this equation. To balance, what is the first step? I have to know which compound should I balance first. And after getting to know the compound, which atom should I balance first? So now here, let's look at that part. So this is the only compound, that is water. There are 3 atoms in water. Whereas in sodium hydroxide, that is NaOH, here also there are 3 atoms. But you see here, hydrogen has 2 hydrogens. So maximum number of atoms are present in water. So we will try to balance hydrogen first. So let's take hydrogen. Now on taking the hydrogen, how many hydrogens are there on the reactant side? 2. Whereas on the product side there is 1 plus 2, in total 3. So in the previous equations, we have seen the occurrence of atom only at one place. For example, oxygen is occurring in water on the reactant side, whereas on the product side, it is occurring in NaOH. But if you look at hydrogen, hydrogen is occurring as H2O in the reactant side. But on the product side, you see it is occurring in NaOH as well as H2O. That means it is occurring in 2 places. So how to balance this is the issue. Where should I balance hydrogen becomes an issue. So whenever you find this kind of examples or this kind of equations, the first thing is check if the total number of atoms are even or odd. So if you look at this, hydrogen is odd. There are 3 odd hydrogens, so the number is 3. And then the next step would be try to make it even. And to make it even, you have to look at the hydrogen which is actually making this whole number as odd. That is, this 1 is making this whole number odd. That means try to make that number 1 into an even number. So how do I make this 1? Here it is occurring as 1 hydrogen. So if I make the stoichiometric coefficient of NaOH as 2, then the hydrogen becomes even. Then 2 on the reactant side, whereas on the product side, 2 into 1 plus 2. Now it becomes 4. So this is the step I did to make it even. You understand this? Whenever you see something odd, you make it even if they are recurring in more than one place. Understand this? Then the next step is now try to balance hydrogen. Now in balancing hydrogen, in total here there are 4 hydrogens. Now here also I should have 4 hydrogens. How can I make on the reactant side 4 hydrogens? If I make the stoichiometric coefficient of water as 2, then it becomes 4 hydrogens. So that means I have to make 2 into 2, that becomes 4. Here also I have 2 into 1 plus 2, which is equal to 4. Now both are balanced. That means my new equation becomes what? Na plus 2H2O will form 2NaOH plus H2. In this, hydrogens are balanced. Now if the hydrogens are balanced, let's go to what? Oxygen. In oxygen, on the reactant side, we have 2 oxygens because this is my new equation. And on the product side, I have 2 into the subscript 1 is 2. My oxygens are also balanced. And finally, I have one more atom, that is sodium. Let's try to balance sodium. Now in balancing sodium, on the reactant side I have only 1, whereas on the product side I have 2 sodiums. 2 into subscript 1 is 2. Now I have to make the reactant side also as 2. Now to make the reactant 2, what should I change? I have to add the stoichiometric coefficient as 2. That means this becomes 2 into 1. This is how sodium is also balanced. And then my final equation will be what? 2Na plus 2H2O will result in the formation of 2NaOH plus H2. Now this is a balanced chemical equation. And before we confirm, we have to check it once whether the atoms are balanced or not. Here there are 2 sodiums, here also 2 sodiums balanced. Whereas here 2 2s are 4 hydrogens, 2 plus 2, 4 hydrogens. Hydrogens are also balanced. Now the oxygens, 2 into subscript 1 is 2 oxygens. Here also 2 into subscript 1, 2 oxygens. Hence this equation is what? Balanced chemical equation. Understood? Let's try to take one more equation which is similar to this. Now let's take reaction of calcium hydroxide, which is given by CaOH twice with HNO3. This reaction is known as a neutralization reaction. Why do we call neutralization reaction? Is because acid is reacting with a base. Hence this reaction is a neutralization reaction. And in this reaction we get calcium nitrate, which is a salt, plus water. Now we have to balance this reaction. So before we balance this reaction, we should know whether the reaction is balanced or not. We have to check for this, whether this equation is a skeletal equation which is balanced or skeletal equation which is not balanced. Let's try to check. So how many calciums are here on the reactant side? If you look on the reactant side, calcium is 1. Whereas on the product side, calcium is also 1. So calcium is balanced. Then how about oxygens? If you see inside the bracket, there is 1 oxygen. 1 into 2 is 2 oxygens, and 2 plus 3 is 5 oxygens. Okay. Whereas on the product side, in the bracket there are 3 oxygens. 3 into 2, 6. 6 plus 1, 7. So it is 6 plus 1, in total 7 oxygens. So oxygens are not balanced. Then let's get back to hydrogens. If you look at hydrogens, in the bracket there is 1. 1 into 2 is 2, plus here there is one more hydrogen, hence total 3 hydrogens. Then here we have only stoichiometric coefficient 1 into 2, that is 2 hydrogens. So this is not balanced, this is not balanced, only this is balanced. Hence we have to balance this whole equation. And there is one more nitrogen here. So if you look at nitrogen, on the product side, on the reactant side, we have stoichiometric coefficient 1 into subscript 1 is 1 nitrogen. Whereas on the product side, we have in the bracket there is 1 into 2, 2 nitrogen. So nitrogens are also not balanced. Hence we have to balance this chemical equation. So what is the first thing we should do here? The same thing that we did to this equation. We have to know which compound should we balance first. So to get to know that, we should know which atom or which compound has maximum number of atoms. Here if you look, all of these are compounds. So in here you have in the bracket 2 atoms, 2 into 2, 4, 4 plus 1, total 5 atoms in calcium hydroxide. Whereas in HNO3, 3 plus 1, here also 5 atoms. In here, we have in the bracket 3 plus 1, that is 4. 4 into 2, 8. 8 plus 1, 9 atoms of calcium nitrate are present here. 9 atoms are present in calcium nitrate. Whereas here it is 2 plus 1, total 3 are present. Then what do we balance first here? Calcium nitrate. So in calcium nitrate, oxygens are present in maximum quantity. That means we have to balance oxygens first. Now to balance oxygens in this particular equation, on the reactant side and on the product side, we have 2 plus 3, that is total 5, and here also we have 6 plus 1, that is 7, which are not balanced. Now we have to balance it. And if you look at this, both these numbers are odd. If they are odd, what is the first step I told you? You have to make this even. Why do you have to make this even? Because oxygens on the reactant side, they are occurring in 2 places, whereas on the product side also they are occurring in 2 places. If they are occurring in 1 place, you don't need to make it even. You will get the balancing easily. But when they are occurring in 2 places, try to make it even. So what is making this number odd? This 3 is making this number odd. That means we have to make this 3 into a even number. So let's see where 3 is in this equation. So 3 is HNO3. So that means this is in the subscript. How do I make this overall thing as odd? If I make the stoichiometric coefficient 2, then 2 3s are, it will become 6. Yes. Then I make the changes that it is 2 plus 2 into 3. So what is the total? 8. 6 plus 2, that becomes 8. Now this is even. Then also I have to change on the product side because this is odd number. Now to make it even, which is making this odd? 1 is making this odd. That means I have to convert this 1 into a even number. Let's look at the product side. So where is 1 here? Here is 1 in H2O. So here, if I want to make this even, if I make the subscript as 2, then 2 into 1 becomes 2, which is an even number. So hence what I will do is 6 plus 2 into 1, this also becomes 8. So now just by making this even, I indirectly balanced oxygens. If you look here, 8 and 8, they are balanced. Hence my new equation will be what? Calcium hydroxide reaction with 2HNO3, which leads to the formation of CaNO3 taken twice plus H2O, that is 2H2O. Here oxygens are balanced now. 2 plus 6, 8. 3 2s are 6 plus 2, 8. Now they are balanced. Then we have to balance what? Nitrogen. So this is the next, which is in maximum in number. So in balancing nitrogen, on the reactant side, I have in the new equation 2 nitrogens, whereas on the product side 1 into, in the bracket I have 1, so 1 into 2 is 2, 2 into again the stoichiometric coefficient, it is also 2. Nitrogens are balanced, correct? Then how about calcium? So if you look at calcium, on the reactant side I have 1 calcium, product side is also 1. Calcium is also balanced. Then let's go to hydrogen. Now in hydrogen, we have 2. 1 in the bracket, 1 into 2 is 2. So 2 hydrogens plus, here also 2 into subscript 1 is 2 in total, 4 on the reactant side. Then how many are there on the product side? 2 into 2, that is 4. Hence hydrogens are also balanced. If you look at this equation, we made only one change, that we try to make it even. Just by making it even, we indirectly balance the whole equation, correct? So what is our complete balanced equation? CaOH twice plus 2HNO3 forming CaNO3 taken twice plus 2H2O. So one final check. 1 calcium, 1 calcium. Whereas oxygens 1 into 2, 2, 2 plus 2 a 3 is 6, that is total 8. Here also 3 2s are 6 plus 2, that is 8 oxygens. Hydrogens are 1 into 2, 2 hydrogens. Again 2 into 1, 2 hydrogens. 2 plus 2 total 4 hydrogens. Here also 2 2s are 4 hydrogens. Hydrogens are also balanced. And then finally let's go at nitrogen. 2 into 1, 2 nitrogens. Here in the bracket we have 1. 1 into subscript 2 is 2. And 2 into stoichiometric coefficient 1 is also 2. Hence the equation is balanced chemical equation. You understand this? So this is what balancing is all about. And there is more to balancing a chemical equation. As I told you, we can get a lot of information from a chemical equation. Let's try to find out what exactly was I referring to. Have you ever seen this equation written previously in the classes? I have written iron reacting with H2O to form Fe3O4 plus hydrogen gas is released. Did I ever write this equation? Now in this equation, what is the information you are getting? Iron is reacting with water to form iron oxide and hydrogen gas. Correct? Now let me do something to this. First tell me if this is a balanced equation. No, na? Here there is one ion. So there are 3 ions. So this is a skeletal equation. Yes? Then how about this equation? 3Fe plus 4H2O forming Fe3O4 plus 4H2. Here 3 iron, here also 3 iron, 4 2s are 8 hydrogens, 4 2s are 8 hydrogens, 4 oxygens, here also 1 into 4, 4 oxygens. Whereas this is a balanced chemical equation. So this equation will not obey law of conservation of mass, but this equation obeys law of conservation of mass. So this is giving some extra information of how many atoms of iron are reacting with how many molecules of water. Correct? Now let's go one more step further. May I write this equation as 3Fe in the bracket S plus 4H2O in the bracket G forming Fe3O4 S plus 4H2G. Did you understand anything that I wrote here in this brackets? Here I have given the physical states of the substances that are reacting and the substances that are formed. Initially, you do not even have a clue that the water is actually in the gaseous state. That means it is a steam that is reacting with iron. But when I written like this, the solid iron is reacting with steam forming iron oxide plus hydrogen evolved. So are you getting some extra information here? So that means we can represent a chemical equation with their physical states in the reactants and the products. We do this only when it is required, or else we don't mention it. You understand this? Now let's take one more equation. Okay, the reaction of carbon monoxide with hydrogen. Okay, this results in the formation of a compound which is known as methyl alcohol given by CH3OH. You will learn about this compound in carbon and its compounds. Okay, now let's see first thing whether it is balanced or not. Is this balanced? One carbon, one oxygen, one oxygens, 2 hydrogens, 4 hydrogens. So this is a skeletal equation. Okay, then let's balance this. If we balance this, it becomes CO plus 2H2 will form CH3OH, which is a balanced equation. Okay. Now let's put the physical states also here. Carbon monoxide here is in gaseous state and hydrogen is in gaseous state, whereas this methyl alcohol is a liquid CH3OH liquid, and this is also a balanced equation, correct? Balanced equation with physical states, it is mentioned. Now, there is more to this particular equation. What exactly I mean is, this particular reaction will not occur under normal atmospheric conditions. Understood? You know, the mixture of carbon monoxide with hydrogen is known as water gas. What is it? Water gas. And this water gas will form methyl alcohol at very high pressures. That is an approximately around 340 atmospheres. Understood? And where did I write the 340 atmospheres? Above the direction of the reaction, the arrow which represents the director of the reaction, correct? So here remember something, whenever there is a reaction which occurs at either certain pressures or certain temperatures or in the presence of some catalyst, we mention them above the arrow in which the direction of reaction is happening or below the arrow in which the direction of the reaction is happening. Understand? This is how we represent. Clear? And let's take one more equation. And this equation, I don't think you are new to this particular equation, that is photosynthesis. What is photosynthesis? What happens in photosynthesis? It happens in plants. So in plants, carbon dioxide, is taken with water presence to form C6H12O6 plus O2 is released with some water. Here plants are preparing what? Glucose, and they are preparing their own food, that is glucose, and releasing oxygen. You understand this? Now let's try to balance this equation. Here it is 6CO2 plus 12H2O, which will result in the formation of C6H12O6 plus 6CO2 plus 6H2O. This is the overall equation. Now this photosynthesis happens only in the presence of what? Light. So that is sunlight. And what is the other ingredient that is needed for photosynthesis to occur? Chlorophyll. And I mention it in the bottom of the arrows. Chlorophyll. Understood? So in the presence of sunlight and chlorophyll, this particular reaction is possible. Understood? And if you are looking at the states of the substances, your CO2 is in aqueous state because it is dissolved in water, which is in liquid state, whereas C6H12O6 is also in the aqueous state as it is dissolved in water. Here oxygen is also in the aqueous state because it is dissolved in water, and this is in liquid state. Understand? And here we conclude all about a chemical equation, how to balance a chemical equation, and what are the other things that we can get out of a chemical equation, like their physical states and the conditions at which a chemical reaction is taking place. Understood? Thank you so much, and I'll see you in the next session.